Good morning and welcome back to a special spring break edition of Chapter 10. In this episode, we will be looking at identifying conic sections. Really, there's two parts to this. The first part is actually very easy. The second part is what takes a bit more effort, and that would be using completing the square to write the equations for conic sections in standard form. We have used completing the square before, but it was way back in Chapter 5, so we'll be re-explaining it here. So, let's look at our learning targets. Learning targets for today. I can identify and transform conic sections. Again, that's the one that's pretty easy. And then I can use the method of completing the square to identify and graph conic sections. That's where we're going to spend more of our time, most likely. So, for identifying, the book has a couple different ways of identifying them, and we're not going to use either of those ways, but they do start out just talking about in standard form. And so I thought this would be a good time to look at just all of the equations together. Now, this isn't all of the equations. For instance, it doesn't have the vertical hyperbola. It doesn't have the horizontal parabola, but it's kind of the general form. Oh, and it also, these are all centered at 0, 0. They're not centered at HK, but it's a standard kind of form for each of the equations. I'm showing you this because on your test, I'm giving you these exact formulas on top of the test. You need to know how to change them into vertical or horizontal for parabola. And you also will need to know how to make sure the center or vertex is at the right spot. But you get these. Why would I do that? Well, we have a lot of formulas, and some of them are very similar. For example, ellipses and hyperbolas are almost identical, except the hyperbola is minus, the ellipse is plus, except for the a squared minus b squared or a squared plus b squared equation. And so having those there, I think, can be very helpful, and there's no reason to have them fully memorized necessarily. So, with that being said, to tell if it's what kind it is in standard form, well, if it's in standard form, you just look to see what it is. What do some of our things have different? Well, ellipses and hyperbolas, ellipse is just plus, hyperbola is minus. A circle is a special case of an ellipse, except that these two, the a squared and b squared, are the same number. A parabola only has an x squared or a y squared. And so if it's in standard form, you can see that. But if it's not in standard form, that's when it gets a little bit more interesting. The book has these equations. You can do this plus this times this minus this, and if it's greater than 0, it's this, and that is absolutely ridiculous. You can do this with a flowchart, just asking yourself a couple questions. So, in general, we're going to look at a flowchart. The first question we want to ask ourselves, does it have both x squared and y squared? If the answer is yes, we're going to keep going. If the answer is no, what doesn't have both x squared and y squared? A parabola. So if it only has an x squared or a y squared, it's a parabola. And if it has neither x squared nor y squared, it's not a conic section. That's going to just be a line. Alright, so if the answer is no, it doesn't have both x squared and y squared, we're looking at a parabola. If the answer is yes, we keep going. With the x squared and y squared on the same side of the equal sign, do they both have the same sign? And again, this is just x squared and y squared. We might have something x and something y later on. Doesn't matter. We're just looking at the squared terms. Do they have the same sign? If the answer is yes, we keep going. If the answer is no, what x squared and y squared don't have the same sign here? The hyperbola is x squared minus y squared, or y squared minus x squared. So if they don't have the same sign, it's a hyperbola. And it's important it's on the same side of the equal sign, because if we added this y squared over b squared, hey, they're both positive, but on opposite sides of the equal sign, that doesn't work. And so, if the answer is yes again, so we have both x squared and y squared, and they have the same sign, do they have the same coefficient? Do they have the same number in front of them? If the answer is yes, well, this is just x squared plus y squared. equals r squared. If we divided by r squared, we'd have 1 over r squared times x squared plus 1 over y squared, or 1 over r squared times y squared. Here, we have two different numbers. If they have the same number in front, it's going to be a circle. And if they don't have the same number in front, it's going to be an ellipse. And these three questions actually work if it's in standard form as well. So let's see some examples on how these work. So this one is in standard form, so we could just look up at standard form. Let's see, we have x squared and y squared, and it's a plus, and our radii are different. This would be an ellipse. Like, you see that this equation matches the ellipse equation. But we can also go through the questions. Does it have both x squared and y squared? Well, this is an x squared, and this is a y squared, so yes. They're on the same side of the equal sign, and they're both positive. And then do they have the same coefficient? Well, this is going to be divided by 4, so it's 1/4, and this is divided by 9, so it's 1/9. So the answer is no, they don't have the same coefficient. And that, again, leads us to an ellipse. How about this one? It's, again, in standard form, but we can go to the flowchart. Does it have both x squared and y squared? Well, we have an x squared here, but this y, nowhere is that being squared. So no, we don't have both x squared and y squared, which means it's a parabola. And doesn't this equation look like this equation? All right, now how about if it's not in standard form? We get something like this. This is where the flowchart really comes in handy. So, do we have both x squared and y squared? Well, here's a y squared. There's an x, but no x squared. So, that's another parabola. How about this one? Let's see, do we have both x squared and y squared? Well, here's an x squared, here's a y squared, so yes. Then, with them on the same side of the equal sign, do they have the same sign? Well, right now they're both positive, but the equal sign's in between them. So let's move that y squared over. 6x squared minus 12y squared. Do they have the same sign? No. So that would be a hyperbola. And so that's as easy as identifying them is. Just ask yourself a couple questions. Again, make sure they're on the same side of the equal sign. That's really the only tricky part that can come into this. And notice when I move that, like, all this other stuff, I don't care about. We just left this, because that's not going to determine what kind of conic section it is. That's going to determine where the center is, what the radii are, things like that, but not what type it is. All we need are the x squared and y squared terms. And so we have identification, which, again, just flowchart, 3 questions, yes or no. And then the second thing that we're looking at is writing them in standard form. And this is going to involve completing the square. Completing the square is kind of weird, and I know the book does it differently than I do it. And when we do it, we kind of work on the 2 steps both at the same time. So we're going to see an example of this. And it's very possible we're going to have to complete the square twice in most of these. So we have a conic section, x squared plus y squared minus 16x plus 10y plus 53 equals 0. One of the things you're going to have to do is identify them. Well, that's more practice from the flowchart. Does it have both an x squared and y squared? Yes. Do they have the same sign? Yes. Do they have the same coefficient in front? We have 1x squared, 1y squared. So yes, this is a circle. But for completing the square, the first step we're going to want to do is group the x's and group the y's. And then the constants, this plus 53, we're going to move to the other side of the equal sign. So we're going to get x squared minus 16x and y squared plus 10y. And it equals negative 53. Notice I left a space here and here because we're going to put something there. We're not done with this step, but we're going to finish this step and do the next step at the same time. And this is where it's a little bit weird, because usually we don't do 2 steps at the same time. So the next step, I have just 1x squared and 1y squared, so we can do the completing the square step. We're going to have x plus or minus something squared plus y plus or minus something squared. This big gap is just so that the x's are close to each other and the y's are close to each other. We'll close that gap after we're done with the step. So we have something squared. What goes here? We're going to take this number, this negative 16, and we're going to divide it by 2 and put it in that spot. What is negative 16 divided by 2? Negative 8. Well, if we have this here, if we multiply this out, we're going to get x squared minus 16x plus 64. So we need to square this number and add it back to the top, plus 64. So the completing the square step, we take this number with the x, we divide by 2, and we take this number and square it and add it back there. Then can I go around adding 64 to an equation wherever I feel like it? Yes, but if I do it, I also have to do the exact same thing to the other side. All right, now with the y's, we're going to do the same thing. We're going to take the 10, divide by 2, so it's plus 5. Notice this one was minus because it was in minus 16. This is plus because it was plus 10. That sign stays the same. So we divide by 2 to get 5, then square it, so plus 25. If we add 25 there, we have to add 25 over here. Now over here we just need to add these numbers together to get 36. So we have x minus 8 squared plus y plus 5 squared equals 36. We can write it without the big gap in the middle now. And that's the equation for our circle. X minus 8 squared plus y plus 5 squared equals r squared. Our center is at 8, negative 5, and the radius equals 6. So again, completing the square. We group the x's and the y's and move the constant over to the other side. We divide by 2 and then square it. And that has to be added to the other side. The other one, divide by 2, square it. That has to be added to the other side. All right, let's look at another one. Here we have 25x squared plus 9y squared plus 72 minus 81 equals 0. So group the x's and the y's. Well, we don't have an x, we only have the x squared. So we don't have to complete the square with the x's. And the y's are already kind of grouped. Let's add the 81 over. And now, over here we had just one x and one y. Here we have 25x, but again, we don't have to complete the square with that because we don't have any x value. We only have the x squared. But we have 9y squared. We need to factor out a 9 here because in order to complete the square, we need 1y squared. So when we factor out the 9, the 72 becomes an 8. And I left the space because we're going to have to put something here. Now we're ready to complete the square. So next step, we're going to have 9 times y plus or minus something squared. The 25x squared is just kind of moving along. What goes in this gap? We're going to divide this plus 8 by 2 to get plus 4. And then up here, we square it to get plus 16. If we add 16 right here, what do we have to add to the other side? No, it's not 16. Look back at this side of the equation. What did we actually just add to this equation? We didn't add 16. We added 16 times 9. And so we have to add 16 times 9 to the other side. And 16 times 9 is 144. So we have 81 plus 144, which is 225. Well, we're almost there. That's the completing the square step. Now, what kind of conic section is this? Well, let's see. We have both x squared and y squared. They're both positive. And then do they have the same coefficient? 25 and 9? No. That makes this an ellipse. What are ellipses equal to? 1. How do we turn this 225 into a 1? No, you don't subtract 224. How else can we turn the 225 into a 1? Divide by 225. So we can divide everything by 225, and then we're going to simplify. I know a lot of people say, all right, so 25 divided by 225 equals something. They're trying to figure that one out. We're going to have a number that goes in the denominator. So instead of doing the top divided by the bottom, do the bottom divided by the top, and then that number just goes on the bottom. So what is 225 divided by 25? 9. What is 225 divided by 9? 25. So we get x squared over 9, and y plus 4 squared over 25 equals 1. This is an ellipse with the center 0, -4, a horizontal radius of 3, a vertical radius of 5, which means it's going to be a vertical ellipse, and we could graph it from there. We've been graphing this stuff for weeks now. Alright, so completing the square, again, we didn't have to do it with the x because it was just x squared. We only did it with the y's. We had to factor the 9 out, and then we had to multiply the 9 by the 16 when we added something over here. So let's try one. See if you can do this. This is a process. Don't just go through and see my answer. Actually try it first. This is important. Let's do 64x squared plus 49y squared plus 256x minus 196y minus 2684 equals 0. So think about what kind of conic section you should be getting based on this stuff. It's going to be a lot like this, except you're going to have to do it with the y's and with the x's. So you're going to get a practice completing the square twice here. Anyway, pause it and come back when you're done. How do you think you did? Let's check. So, first step, we group the x's and the y's. So we just rearranged them. And we moved the 2684 over to the other side, the equal sign. Now we need to factor stuff out. Factor 64 out of the x's. So we end up with 64 times x squared plus 4x. Leave a space. Plus 49 times y squared minus 4y. Leave a space. Equals the 2684. Now we're ready to complete the square. So 64 and 49 move down. The x plus 4x becomes x plus or minus something squared. The y minus 4y becomes y plus or minus something squared. So we have plus 4x, or plus 4, so we divide by 2 to get plus 2, and then square it to get plus 4. Then what do we add to the other side of the equal sign? 4 times 64, which is that 256 again. Over in the y's, we have -4, divide by 2, it's -2. Square it is plus 4. Notice these are always positive because we're squaring something. 4 times 49 is back to the 196 number. So we add 196. Add those together. We get 3,136, which this is an ellipse because x squared and y squared we're adding, but we have different coefficients. So we want it equal to 1. So we divide by 3,136. It turns out that 3,136 is 64 times 49. Hey, 225 was 25 times 9. That'll actually happen a bit this year. It doesn't have to, but when the problems are set up to work out and be easier, that happens a lot. So 3,136 divided by 64 will give us a 49, and divide by 49 will give us a 64. So we get x plus 2 squared over 49 plus y minus 2 squared over 64 equals 1, which, notice it's an ellipse. The center is at -2, 2. We're going over 7, and up and down 8. So it's a vertical ellipse, but it's really close to a circle. Anyway, so that's completing the square. This one had pretty much everything in it. You had to complete the square twice. You had to factor out both times. The numbers were big. The only thing it didn't have was you didn't end up with any kind of fractions in here, which doesn't happen very often anyway, at least not this year. And that's the toughest thing. Do you kind of remember doing that in Chapter 5? I know a lot of people in Chapter 5 kind of got around completing the square because there were ways of getting around it. There aren't any ways of getting around it anymore. You actually do have to complete the square. And yes, you will have to do it on your test, and it's a process, but it's the same thing. There's just a couple steps, and we'll be practicing it a bit. So anyway, I hope that you are enjoying, or have enjoyed, or will enjoy your spring break, and I will see you on Monday.